Good day all. Now let us learn a new trick which doesn't use the normal KVL or KCL rule and you have to form the equations with the loops and then solve the equation to find the currents. Now let us learn a new trick which is called the new trick or a theorem. Okay, a theorem which is called as a Millman theorem, through which you can solve the problem super quick, right? Now this theorem states that when a resistor and a voltage source is connected parallelly like this, these kind of resistors can be converted to a single resistor and a single equivalent resistor and a equivalent voltage, right? Now here in this part where the AB is connected, here just a single resistor can be connected, or it depends on the question. Okay, so when you get the final circuit as this, here you can, if it is joined like this, now you can directly use Ohm's law, that is V is equal to IR, and find the value of I, right? As you know the value of V and you know the value of R, so you can find the value of I. So the problem gets really very simple and you can find the current, right? So to solve this you can use this formula to solve. So let's learn how this formula is used. Okay, now here the two main components are used. In Millman's theorem we have two main components, which is nothing but R equivalent and V equivalent. R equivalent is given by 1 by root of 1 by R1 plus 1 by R2 plus 1 by R3. So here 1 by R1 is this resistor, and R2 is this resistor, and R3 is this resistor. Remember, this Millman theorem can be used to solve infinite resistance connected like this. Okay, so you can add how many ever resistance you want. It can be extended till 1 by Rn, right? It can be extended till how many ever resistance are connected like this. Okay, then V equivalent is given by V by R1 plus, here also we have plus or minus, right? Plus or minus V1 by R1 plus or minus V2 by R2 plus or minus V3 by R2 and so on. Here also n number of voltage sources can be connected. Okay, so divided by this 1 by R1 plus 1 by R2 plus 1 by R3. Here you can ask, what is this plus or minus? Here how to determine whether it is plus or minus. For this you have to remember a simple strategy. What is that is, here from view the circuit from the top. Okay, view the circuit from the top. If in the first branch you find positive terminal and then the negative terminal, right? So here the value of V is positive. Now in the second case you find negative and then the positive terminal of the battery. As it is negative, here the value of this is negative. The third case it is positive and then negative, so here it is positive, so in this case it is positive. So what is so to determine the value of signs, whichever terminal of battery comes first in the circuit, we have to put the value of put this sign similarly. Okay, so then you can, so this is how you get R equivalent and V equivalent. And now you have to connect the circuit just like this and then solve the problem. For example, let us consider this circuit. Okay, now this in this circuit they have asked to find the current flowing through the branch AB, right? So here you can convert this, that is you can rearrange this circuit as shown here, correct? So after rearranging this, now we can directly apply the Millman's formula. Here it is very simple, as only two resistances are connected, so you can directly apply the formula. So this comes around like this: one here resistance and the voltage source which is connected to AB. This is A and this is B. You end up getting like this. So when you find the current flowing through this, that is using V is equal to IR formula, using V is equal to IR, that is the conventional Ohm's law. Using V is equal to IR, you can find the value of current flowing through A and B. This is really very simple as compared to normal method where you have to mark the currents flowing through each branch and then form equations, and then you have to solve for that, where you may undergo many errors, and then finally it is really very time consuming and it may not be very accurate. But this method is really very fast. You can do it really very fast, and the answer will be exactly correct. Okay, so I hope you must have understood this. Thank you.